Recording in progress. Hi all, today we'll speak about what is a difference between a container. Hang on. So I had an issue with my notepad, but anyway, I have resolved it. So we'll today speak about what is a difference between a container and a VM, why we need a VM, and why we need a container. So let's see how the VM used to work. So if you have hardware and then you install a hypervisor, let's say ESX by VMware, on your hardware, and then you used to have VM1 to VM n number of VMs as much as your ESX supports. And then these could be from any flavor. It could be from Windows platform, it could be from Linux platforms. So there's no restriction as such. So uh, to to run a VM, you actually need a hard disk, and then you can assign networks or the NICs to your VMs, and then you can assign RAM. You can assign how many CPUs the VM will have, and and to actually user it does not the user will not find out if it is he's running a VM, or in case he's running the VM directly on hardware to which he's doing the RDP or anything else. But why we need containers if we have VMs? So containers, basically how containers work is that you may have a OS that may be sitting over a direct hardware as your laptop. It could be installed on an ESX that could be running on a different hardware. And then on this OS, there is a separate process you can run, which is a Docker process. And then on the top of this Docker process, you can have containers. You can have n containers running on your OS with the help of Docker process. And the limit is how much your OS could support, the resources of your OS could support. So why we need a container when you have a VM or vice versa? So what happens is that to spin off a VM, it starts off a lot of services, and it may take an easily 20 seconds plus to actually get powered on to start up all the services. And then it will have a dedicated hard disk where an OS would ideally take more than 3 gigs, if I'm not wrong, to just be running on the VM. And then you have a separate list of NICs attached to it. And then you assign a RAM, you assign CPUs to it. So it essentially is a separate machine running inside a separate hardware. But in case of containers, if we speak about, so containers, you can run container over, and let's say Ubuntu OS, and then you install a Docker process on your Ubuntu OS. There you run your containers. So oh, to run a container, it does not get bundled with its own operating system. It actually just offloads the memory management and all the work done by operating system to the actual underlying Ubuntu OS on which the Docker process is running. So it essentially is not is does not come with a separate OS and isolated OS. Suppose you have two containers, one is container 1 and one is container 2, let's say C1 and C2. Both of them will not have a separate copy of operating systems running inside them, as was in the case of VM1 and VM2 when you deployed on ESX. So with that said, I think powering on a container or giving it a life from an image would be faster than giving a VM a life from an image. So let's say in a case where you want to spin off 1,000 instances of your new upgraded service or a new service which you are deploying. So you want to do that within 5 seconds or under that. So if you want to do the deployment between the VMs, that would actually take a lot of time, and you would not be waiting for those VMs. And let's say one of the VMs gets down, one of the services which is running in VM2, suppose you have your VM 100, 1 to 100, and VM2 has got into a problem. To replace, you need to always have 100 VMs running in your load balancer. Suppose you're running a service. So in case you want to recreate a VM2 with a fresh copy of the service code, it will actually take some time. While you do that with containers, it does not. So that is where the containers came into being. And when you actually, it is not that you deploy a Docker process on each of the servers and then you go to each of the servers and do that stuff for creating a container, upgrading a container, destroying them, or just provision them as you want. But then there is a software that helps you do that. So the software is Kubernetes. It was actually called as Minion first. So when we speak about what is a Minion, if you have seen, they get a life, they do some work, and then they go off. So those are designed to do some particular task, and then they go off. And they are very small. And as you see with containers are very small. So they were initially called minions, that they get a work, they do it, and then they go off. So Kubernetes is a container. So let's say you want to deploy 1,000 containers as an example over your hardware. So hardware could have a lot of VMs or the actual servers, which might be running an operating system. Let's say you're running a Linux OS. So it could be a VM where you install your Linux OS, on which you install your Docker, or it could be the actual hardware server where you install Linux and then you install your Docker process on the top of it. You might have, let's say, 10 servers. For now, let's call them servers, where you want to deploy 1,000 containers of image Nginx. Right. So each of them might have 100 instances per server, and Kubernetes saves your time so that you do not log into each of these servers, run the command of Docker, and then create 100 containers per server. So a server in Kubernetes architecture is called a node. As I said, node can be a VM, it can be an actual OS on a dedicated hardware to run just those run that OS on which the Dockers run. But it could be VMs too. And to Kubernetes, it does not matter where the VM runs unless and until you configure your networking so that different containers can talk to the other containers sitting on different nodes. So let's say you have currently node 1, and then you have node 2, where you actually have Docker process running individually, and K8 ask the deployment to get scheduled on both these nodes, and it actually load balances the load these servers might be tackling. These nodes can be tackling, node 1 and node 2. Suppose you deploy 100, it could be that you deploy 50 and 50 on these nodes, and then suppose you want to deploy another image, it sees which nodes can take that load based on the current usage of that node. So let's say you get your load balanced, and suppose now you're running a API version 1.0 on these nodes, node 1 and node 2. And now you want to go to 1.1. So Kubernetes helps you to do these deployments where it actually downgrades or actually reduces the number of instances running on each of these nodes. Suppose you have initially 50 on each node. So it could be that 40 it actually destroys 10 Docker images, and you have 40 running with 1.2, and then you have 10 which are running on 1.1, and then it does that uh, in a sequential manner, or step by step, so that in a node you can actually have 50 versions of running 1.2. We'll talk about deployments later on, but doing your deployment is far more easy when you do with Kubernetes. And the benefit of doing this is, suppose you have an image where there's a step file, or there's a Docker file. We'll talk about all this later on, where you define the steps to take for an image to get a life. You may tell that you might go to Git and then download the code. You might run some HS file. You might open some ports, and then you start listening to some of the queues. So all this can be written in a Docker file. But what if all this has to be done in VM? It could be very tedious. So you just create a Docker image, and then you put it over a hub and tell Kubernetes, I want this image, let's call it image 1. And then you want to get 100 instances or 100 containers running from that image. So it is doable. And it could be that, suppose you want to increase your number of nodes, and suppose the user base is increasing. So now you say that I need 2 additional nodes. So to Kubernetes cluster, it does not matter that you just plug and play your nodes, and you just add a node to a cluster. And to Kubernetes, it is very easy. You can just add your nodes on the fly. We'll talk about the details of the architecture of a Kubernetes, where one is a master, what is the role of a master, and how does it schedule, where does it store the information of which node is running which containers, and and all that. So we'll talk about that in the next video.